Good evening, and as promised, I am going to show you how to access the CDC's VAERS, or Vaccine Adverse Event Reporting Systems files, and upload them at the exact same time so you could scrape data from them. Now, tonight is a wonderful example to how mistakes are being made in reading the data from the VAERS site, which generally can, how I describe it, lead to very, very, very smart people uh, making erroneous, I don't want to say erroneous, that sounds bad, uh, misled, being misled claims. All right, for example, this one, I have incredible respect and they're very intelligent individuals. For example, RFK Jr. made a statement on the Tucker Carlson show. Now, what we're going to look at is basically how this error can possibly occur. I'm not certain if this individual misread the database or someone fed him incorrect information, but you can get an idea on how this can happen. So here we have it. So RFK Jr. in the article is quoted as saying there's been 17,000 deaths reported to VAERS from COVID vaccines. Now, what you and I are going to do is we're going to look at how two things on how we can basically look at this data through Python, and at the exact same time too dwell on how an individual can potentially make that error. And it's going to come together. Are you ready? Let's begin. All right, so first, as promised, what you're going to need to do is you're going to need to go to the CDC site, the VAERS Adverse Event Reporting System site. From there, you look at 2021. Now, see, an argument in reference to the number of reactions being reported, you and I, which have been covering this for quite some time, know that we've had more reactions reported to VAERS than the prior 30 years combined. That is pretty evident just in the size of the files. For example, 2021, 564.83 megabytes. That is approximately the size of a video game. A basic one today. But look at the size for last year, it's only 42 megabytes, and it goes down the line. So the argument in favor of there being more reports to VAERS than ever before is not a misnomer. But to proceed, what you're going to do is you're going to download the VAERS data, you're going to download the VAERS symptoms and the VAERS vaccine. From there, what you are going to do is you're going to upload those files, as you see right here. You're going to upload them into your notebook. Again, I'm talking to individuals which are like myself, Python amateurs, and other data analysts which have a little bit of experience with Python. But what I'm working on right here is basically Jupyter Lab in reference to Anaconda. So if you see the site, that's exactly what it is, but it's Python is Python. Then what you will do, and I'll post all this code under the description of our YouTube site on VH Film or my personal site as well. So you can just, don't have to, if you don't memorize it, I'm not going to explain exactly how the code works. I just want to get you started. All right, so first we import the modules, pandas, and regular expressions, or rejects, whatever you want to call it. All right, now this part's very important. What you're going to do is once these files are uploaded into your notebook, what you're going to do is you're going to read these CSV files. The trick is this, and this is why a lot of people run into errors. You must have it encoded in Latin 1. Encoding in Latin 1 is an incredibly crucial aspect to your code and reading the CSV file, as well as it'd be helpful to set low memory to false because, again, the file size is huge. All right, so let's upload those files. There we go. And then what you can do after that, if the uploads, we can basically look at the head of the data, and it should be uploaded right now. Let's give it a second. There it is. All right. Now this is the VAERS data, for example, right here. And that is basically quite a few columns. You can see across the stage there. All right. Now, here we go here. Next one, the vaccines. You see what's happened? You have the vaccine type, manufacturer, lot numbers, dose. Lots of fun things you can mine from the data. As far as, for example, out of curiosity, I don't want to say fun because these are really serious reactions, which I'll show you how to read in a second too, because it's pretty tragic. But as far as data analysts and data or analyzing the data, this is at least just enough to get you started. All right, then the symptoms. All right, this part's important here. Symptom 1, 2, 3, 4, and 5. And this is how the error, for example, from certain individuals or their staff is being, how to say, acquired. Because when they say 17,000 deaths, and the reason it's important, and especially for you if you're data mining, is this. And this is why we're covering this. It's a beautiful example tonight of what the problem is. All right, you see VAERS IDs. Now, the problem with a lot of the reports is you only can file 5 symptoms. A lot of individuals have been so devastated for one reason or other correlating with the vaccine that you'll have one ID, but they may have 20 symptoms. So when they have 20 symptoms, the medical professional or the individual itself will basically have to file 4 separate reports. Now you see how you have conflation, how you can have confounding. So one individual may have one ID, let's say, for example, 916600, but 916600 may appear 4 additional times because they had to fill out 20 reports. Now let's look at the duplicates. All right, so we have 224,248 duplicates. Whoop, one second here, one second. So when you have so many duplicates, you could see more how RFK Jr. can basically arrive at that error, or basically his advisors arrive at that error. So generally focus on this number here, 665,460. And so let's look at the length of each data frame. And what you're going to be looking at probably more than anything else, I should say, focus on this number here, 665,463. This is going to be an indicator of exactly how many IDs there are. And so not the duplicates. So for example, you check out the symptom duplicate, you see 889,708. Well, how can you have one data frame with 665,463, another data frame with 889,708? Then when you combine them, there's a little bit more conflation, but let's begin. All right, so let's see what happens here. And there we have the same number. So we're really looking to arrive at a number of about 665,463, plus or minus a couple digits, but not digits, ones or twos. And so there you have that. And so there's your data frame. Now, what we have to do is merge the data frames. And to merge, first we're going to merge this frame here with this frame here. And this is going to make the data mining a lot easier. But you have to keep in mind the duplicates. You have to remove the duplicates before you come to any solid conclusions or correlations. So there we have it. We merge the files. So we merge those two, merge the vaccines with the vaccine data. And if we look at it here, you see all the columns across the way, quite a few columns. Lots of information, all the way across the board. Dates, the whole lineup. Now what we want to do is we merge the last basically CSV file as we have here, and that is this one here, the symptoms. So you'll see that up here on the end because we're merging outer. Here we go. And this will give us our master frame. So there we have it. We merged that frame. Now keep in mind too, let me take this back. We are merging on ID, VAERS ID. We are merging on VAERS ID. And because it should be the most common thing out there, and we're not deleting any IDs by merging it the way we're merging it. Again, I'm not going to go too much into explaining the code. I just want to have it posted for you so you can see how it works. And there we have the symptoms all the way there, correlated with the IDs. Now, let's look at the duplicates. So here we go. How many duplicates do we have? How many VAERS IDs are repeated over and over again? So in the master data frame. So there we have the number, 665,463 solid IDs, as we said before. And we're showing now 276,848 duplicates. Let's look at our columns by name. And here we go. This is our master column. These are all the columns which we have now in our data frame. Now, not all, some of these are superfluous and so on and so forth, but you can see the information that we can basically extract from the data frame itself. Now, how do we do that? I'm going to give you a couple different options, real basic, but here we go. Let's say, for example, we want to look at, again, the code is going to be there in the description. So again, just follow along with me to see how it works. All right, so we're going to be looking right here is see right there the string comma. So we're going to find out everyone in the symptom text, which is right here, not the symptoms down here, which we could use for other reasons. But otherwise, I'm just going to go into the descriptions that are being submitted by either the medical professional or basically the person who had the reaction themselves. So here we go. All right, let's do this. And this is why we need to import regular expressions as well. And so now what we're going to show is basically it's going to go through the entire data frame. It's going to go into the symptom text here. And if there's a word comma there, it's going to pop up. Now here we go. Now we have to eliminate the duplicates. All right. So there we have 1,805 rows, which are showing the word comma. Now we have to remove the duplicates. So here we go. Because it could be the one ID can have comma mentioned a bunch of times in the symptom text. So here we are. We're dropping the duplicate VAERS IDs. So we just have one ID and we keep in the first one. You want to keep the first ID because chances are that's going to have a majority of the information. The reason we did not eliminate the duplicates in the beginning is because since an individual can file multiple reports, let's say they're filing 5 reports, the word comma could be in the 5th report. You see what I mean? So you're just keeping the report with the word comma in there, and you're eliminating the remainder. So here we go. And so there we are. And then if you want to read the information, because obviously it's a little difficult here, and with a number of columns, because you're cut for room. So what we'll do is we'll expand the column width. All right, now we'll look at the VAERS ID in the symptom text. And now you can be able to mine the information as you see. And as you read these, the symptom text in these VAERS IDs, these are not to be taken lightly. They are pretty detailed and they are descriptive and they are really, really sad to read. And so that can basically install some biases, but they are emotional descriptions, and a lot of them have not ended well. Now, how did, for example, a lot of our popular individuals make that error that we just saw a little while ago? And I have tremendous respect, but I want to make sure the argument is done in the proper pretext because it's important. Now, another argument that can be made in reference to how that number could be arrived at is that only is claimed, and there have been studies as well, that only a small percentage of actual reactions are reported to VAERS at all. And you'll hear numbers as low as 1%. Now, that's unfortunately each case is different, and that it can install conjecture or bias, and more research has to be done. But we have a ton to begin with to start with. So let us begin with looking at that. So I'm not discounting the claim. I'm just showing you how that error can be possibly arrived at. So now we look at the mortality, and this is what we're looking at. And here we go. All right. We're going to basically set the column width to 100 so we don't fill up with too much words. And what we're going to do is we're going to query from died. Now, this is a really easy Boolean query because all you have to do is send to go through the symptom text. You see right here, right there, you see why. Unfortunately, that individual had succumbed. And then basically what ended up happening is that ended up being reported to VAERS as a potential vaccine reaction. So there's a lot of Boolean things that you can utilize, and you could pick up and pull out information that way. So we're going to use the query method. And so here we go. All right, and there we are, died, Boolean, y. All right, so basically there we have we're printing out, and we're going max columns, and these are all the IDs. Now you see that number right there, 16,373. Now you have a strong hypothesis. How did the person potentially make that error? Well, they potentially made that error because one of the advisors read this and just stopped there, not recognizing that IDs, like you and I have now recognized, can be duplicated. So what is the duplication? If we remove them, and for example, on the mortality, there we have. What do we have? 8,712. Why? Because it dropped the duplicates. So it almost cut it down by about 40% or so. And then from here, if you want to read, unfortunately, a lot of the tragedies, these are not people that are just saying, oh, well, this is background information or just pure coincidence. These reports need to be taken seriously. And I honestly don't believe there's enough CDC officials on hand to investigate all the safety signals which are arising. But in short, for individuals on how to basically utilize the code to pull up the data, we're going to reset it real fast. So all of it will be in the description. Restart kernel, clear output. Just to go through it fast. All right. Basically, first you download the data from VAERS. You can't, it's difficult to scrape because you're going to scrape it on your own. You're going to run into CAPTCHA and that holds you back. Download the 3 data files, 1, 2, and 3. From there, you basically load the modules, regular expressions, and pandas. Upload, I should take the back, upload your CSV files to whatever your notebook is, whatever it is. From there, read the files. From there, just check your data. It's always a good idea to do. And as it goes through, give it a second. And then obviously from there, you can explore your data, for example, as follows. Check the length of the data frames. You're just trying to make sure you're not making any errors, or at least get an idea on how to handle those data frames. All right, look at a number that you want to really, you're aiming for to make sure you have some sort of a semblance of accuracy. All right, there's that. Merge your data frames as we're doing right here. Again, the code will be there. Not explaining how it works, but there it is as is. We merged one, then we merged again. I'm not interested in multiple merging of a data frame per se, just easier to just do it that way. Check your columns out. Whoops. Let's first look at our value counts. Again, for duplicates, as I showed you before. Put whatever word you want to put in there. Let's put blind. All right. Pretty macabre per se. That's how you string contains. You could do multiple words as well if you use an and or type function. All right, give it a second. These are all the reactions which came up blind. Then just hit it again. You drop your duplicates, and instead of having 1,255, you have 626 actual IDs, as opposed to multiple IDs or one person duplicating IDs. And then if you want to read exactly what happened, you go through it, and these are all the individuals that somehow lost their vision and related it to potentially vaccine reaction to VAERS. Again, very detailed. These are not just people just making things up because they had a bad day. Column widths, and then you use query method at the exact same time if you want to, if there's a Boolean column for that, and then you take it from there. Again, the code will all be there. Once you have this code down, you'll be able to mine it like an amateur like me. I was about to say a pro, but it will basically shield you. If you make an argument against or for inoculation, it is vital that your data is accurate. Otherwise, it could discredit, even if you're right, it could discredit your motivation. And again, these are very, very brilliant people. But however, mining data is a skill. And unfortunately, it's a skill which is not as common as we would like it to see. And so by getting a good head start this way, I hope it helps and you can get at that data frame and just check it out from there. Again, Ralph signing off. See you all next time. Bye.